Hello everyone. Today we are going to work on the movement part of the move command. In the last episode we implemented an interface called navigable interface and implemented that on our base pawn class, and then we used it to move the character around. Today we are going to implement an actual movement, because last time we were just snapping to the location, to the given target location, rather than just walking it like this. So we are going to implement the actual movement today. And note that we are still not using any kind of navigation. We are still just moving them in a straight line. We will eventually work on actual navigation too, but right now we are just implementing the move commands, and actually that's it for now. Also we will work on the rotate into the direction of the movement, and also we will add a simple animation blueprint too. Right, so before we get started, as always, let me remind you that you can download the project files of this project and all other thousands of projects I have done in my channel from this Patreon page. And also, once you become a member, not just this project, you can download anything without any limits. So also here you can see in this playlist all the tutorial episodes of this tutorial series, so feel free to check it out. And also there is another strategy type tutorial series that I have done before, but that is based on blueprints. Unlike this one, I'm doing it exclusively in C++. Here everything is done in blueprints, so if you are interested in that, feel free to check it out too, and I'll leave links to everything in the description. Right, now let's get back to today's episode. Okay, so as of the end of last episode, this is what we implemented. I can select a character and snap it to some location using the move command. We still have to implement a smooth movement, so that's what we are going to do today. Okay, so let's directly jump into our code, and here in this CLM base pawn, last time we added these two variables, effector move target location and b moving boolean variable. So now here in this move location implementation, instead of just setting this set actor location, I'm gonna set the move target location like this and set b moving root row. Alright, now here I'll add another protected u function called void move. Okay, and in the tick here I'll call move. So let's implement move now. First thing is, if we are not moving, that means if this b moving is false, we should return. Let's do an early return, so nothing is executed if we are not moving. But if b moving is true, this will become false and this return will not be executed. So here goes the movement logic after that. So first thing we need is, in order to give a movement input, let's have a vector direction, and this would be simply this. Get the move target location, and subtract get the location. So this difference would be the move direction. So if direction is larger than some value, if I use it 50, that would means this would be like the acceptance radius in the usual mode function that we have in the blueprints, which represents the minimum distance we need to have in order to consider that we have reached the given target location. So instead of hard coding this, let's add it as a variable maybe here. Acceptance distance equals 50. One thing is, if needed, we can actually insert this. If we can actually pass this acceptance distance as a parameter too, you will just have to go to the navigable interface and add an additional parameter here. But right now I don't need that, so I'm just gonna use this acceptance distance just like this. So yeah, if you pass it, you will have to set the acceptance distance with that. Okay, so acceptance distance. If it is larger than acceptance distance, that means we still need to move. Well, actually, let's do an early return here too. If it is less than acceptance distance, then let's set be moving to false. Return. I'll comment. Early return, not be. If reached destination. Is reached. Okay. Command also starting to look like the code. Okay. Now if none of these early returns taken place, that means we have to move. So we can add a movement input, but for that we usually need to use a unit direction vector. So move direction, let's normalize it to give tolerance maybe 1. Okay, and then add movement input. Direction is move direction. The scale is 1. Should be it. So this will automatically work because we already have added a floating point movement component. Now note that here we are not considering any kind of obstacle avoidance, navigation or anything. We just simply move the character to the target location in a simple line, along a simple line. No obstacle avoidance whatsoever is applied here. That is something I'm planning to implement later on, but for now, just this. Okay, now let's save and compile. Done. Okay, they are moving. Looks good, but they're just not rotating towards the direction that they are moving, and also they don't have animation too. Alright, first let's fix the orientation. If we had used the character template, we will all have a orient rotation to movement property by default, but here we are using a pawn and with the floating moment, so we have to do it ourselves. So to do that, to calculate rotations, we need to use this 𝐒𝐻𝐻 math library because we need to get the rotation from x vector. Okay, so after adding the moment here, f rotate desired rotation equals, we have the moment direction, so u 𝐒𝐻𝐻 math library rotation from x, rotation from x, yeah, that's the one, and pass move direction. Okay, now, well, either I can just simply set the rotation or I can smoothly rotate it. First, let's simply set the rotation. Set at rotation desired rotation, and also you might see here how we can combine. Okay, okay, so it did work, but it's not smoothly rotating. Depending on what you want to implement, that may be fine or not, but here not something. See, character is now have an angle. See, so we need to avoid that. So for that, here desired rotation, we need to zero pitch. That would avoid having an angle on the character. It will only rotate around the Z axis. Now, and the next thing is, if you want to smoothly rotate, you can use this. Here, let's have a new rotator. If math or enter 2. So we are interpolating the current rotation of the character and the desired rotation. So current rotation of the character would be get at the rotation. The target rotation is desired rotation, and the delta time get world time seconds. Delta seconds. And here we need to give the interpolation as speed. So maybe we should have a variable for that. Float character turn speed. Let's just use 5. Turn speed. Alright, and now instead of desired rotation, use this one. New rotation. And by the way, if you want to allow these to modify in in the blueprints, you can do this. The massive properties. These two, if you want to access them within blueprints, you can do that. But right now I don't see a use, so I'm not gonna. See? See? Now they are not snapping the direction, the rotation. They smoothly turn. Right. And if you want to modify their speeds, here, the controller, character, base bone, floating bone movement, max speed. Change it to whatever you need. That seems reasonable. Alright, now all good. The only missing thing is the navigation and the animation. From those two, maybe we should fix animation first. So, to fix animation, actual animations are usually handled in blueprints through the animation blueprint. So, I'm not gonna use C++ for that, because even the C++ example project in Unreal comes with the Unreal Engine also uses an animation blueprint. So, why me? So, click, create anim blueprint, ABP, night, because the character's name is night. So we are not going to do anything complicated here. A very simple animation blueprint. So let's just create a 1D blend space. Night running and night walking and night idle. Okay. Can you create a blend space selected too? Oh, we can't create a blend space there. Okay, here we can create blend space 1D. ABSP 1D. Here we have the animations. Let's set horizontal axis, speed, maximum axis value. I think maybe 600. Idle for 0. With divisions. I don't see divisions. Are they? Are there? Running in this end. In here. That's the value. For 43. Needed. Okay. We can always come back and change these values. Let's just drop it here. Connect. Let's promote this speed to a variable. Okay. Now the event graph. Here we have blueprint update animations and drag it phone owner. Okay. Let's check if this is valid first. It's valid. Okay, yes, then get velocity and length. Maybe consider only with xy. Come on. This no, we already have a speed. Let's call it horizontal speed because this only matters for a movement in the horizontal space, not for falling. So set it like this, right? And that should be all for the animation blueprint for now. Let's use this for our character baseball. Here we are using an idle animation, so animation blueprint ABP night. Okay, now that's it. Okay, nice. The movie. You see some slight mismatch in the speeds. So, and just set this. Right. And also let's set the movement speed also to 300. Oh, that seems good. Okay, so all good. That's all I want to implement for today. Okay, so thanks for watching. As always, updated project files will be available here. Next time, maybe let's work on an actual navigation rather than just moving to a point in a straight line, so that we can avoid obstacles, find paths, things like that. And yeah, let me know if you have any questions in the comments below. See you in another episode. Goodbye.